Okay, now let's move on to problem number 12, in which we have to find the area of the shaded region in the figure that is given to us. The region is bounded by parabola, the parabola y equals to x squared minus 4x on the bottom part, and on top the region is bounded by the line y equals to 2x. Now, the important principle to know here is that we can calculate the area of any region in the xy plane by integrating the length of its cross-section. Now, in principle, we could use any cross-sections. We can use horizontal cross-sections, we can use vertical cross-sections, we can use slanted cross-sections, but depending on the situation, it may be easier or more difficult to use one type of cross-sections versus another type of cross-section. Let me redraw this picture here. So we have a parabola like this, and then we have a line, and the graph is in red. And we are looking at calculating the region, the area of the region that is bounded by this line and the parabola, the shaded region in the graph. And so what I want to illustrate here is I want to show cross sections of this region. So so imagine I'm slicing this region by vertical lines. Then I'm going to get these cross sections. So here's one cross section. It's a vertical line segment that begins on the blue parabola and ends on the red line. It has a certain length. So when we refer to the length of the cross section, we refer to the length of such interval. Now, if I move my cross section to another location, so for example here, it will have a different length. Even further to the left, we can see that our cross sections become shorter and shorter and shorter. And also, if we move to the right, likewise, our cross sections become shorter and shorter. So this is to say that the length of a cross-section really depends on the position of the cross-section. Now, the position of a cross-section may be determined by the x-intercept of that cross-section with the x-axis, right? And so, depending on the x value, the length of our cross-section may be larger or shorter or smaller. And the key principle that I was talking about is that to calculate the area of a region, we need to integrate the length of the cross-section. On some interval a to b. Now, the limits of integration are essentially determined by the range of the variable, which determines the position of our cross-section. In this case, for vertical cross-section, the variable that determines the position of our cross-section is x. In the next problem, we'll be using horizontal cross-sections. In that case, the variable whose value will determine the position of the cross-section will be y. And so when we're looking for, let's concentrate on this case here. Since x is the variable whose value determines the position of our cross-section, the interval of integration is essentially the range of x values for which we get a non-zero length of the cross-section. Now you notice, of course, that if we go to the negative range, right, if we're somewhere here and we draw a vertical line corresponding to that x value, you see it does not cross our region at all, so there will be nothing in the cross section, and for the negative values of x, the length of the cross section is 0. And from the picture, we're actually given the intersection points for the line and the parabola. The left intersection point is at the origin, 0, 0. The right endpoint intersection of the line y equals to 2x and our parabola is 6, 12. And so we can actually see that the rightmost point in our region is that point of intersection with the x coordinate equals to 6. So for the points in our region, and so somewhere here in the middle of this region, anywhere here, the x coordinate ranges from 0 to 6. And that is our interval of integration for this problem. Okay, so more precisely, we will integrate from 0 to 6. Now let's see how we can calculate the length of the cross-section. Let's look at one of these cross-sections. Maybe the one that I indicated here. I'm going to indicate this cross-section by making it thick, but it can be any of the other cross sections that I drew, or maybe the one. It could also be one that I didn't draw. So this is just a typical cross section. Now the bottom end point of this cross section lies on the parabola, so therefore we can determine the y coordinate of that point from the equation of the parabola. Y equals x squared minus 4x. Now on the top end point of our cross section is on the line y equals to 2x, and therefore the y coordinate will be determined as y equals to 2x. Now for a vertical line segment, to determine its length, all we need to do is take the y coordinate of the top end point and subtract the y coordinate of the bottom end point. So the length of our typical cross section will be 2x minus x squared minus 4x. When you do this subtraction, it's important to put x squared minus 4x in parentheses, because we'll be subtracting that entire value, x squared minus 4x, and not just x squared. And then we integrate all of this with respect to x from 0 to 6. First, to integrate this function on the interval from 0 to 6, first let's do a little bit of algebra. So I'm going to distribute the negative sign. 2x minus x squared plus 4x dx. Now I see two common terms, two similar terms, 2x and 4x. I can combine them to get integral from 0 to 6, 6x minus x squared dx. And now we can integrate term by term using the power rule. Antiderivative of 6x is going to be 6x times x squared over 2. And then minus the antiderivative of x squared is going to be x cubed over 3. And we will be plugging in our limits of integration, 0 and 6. And let's see what we get. The first term in the antiderivative simplifies to simply 3x squared. And now we have minus x cubed over 6 plugging in 0 and 6. Note that when I plug in 0 for x, the value will be 0. Let's see what happens if we plug in 6. We get 3 times 6 squared minus 6 cubed over 6. Now 6 cubed over 6 is 6 squared. And so essentially we get 3 times 6 squared. Actually, I think I'm making a mistake here. So I have 3 times 6 squared. Yeah. And then I have 6 minus, actually here is a mistake. I need the antiderivative is x cubed over 3, not over 6. So when I subtract, I will have to subtract 6 cubed divided by 3, not 6. And so it's so I'll get actually 3 times 6 squared minus 2 times 6 squared. And so it's just 6 squared, which is 36, and that is our answer here, 36.